Right, well, we'll go ahead and get started. So today we're going to be talking about what is digital manufacturing and why would we want to adopt that. So I'm going to be your presenter today. My name is Joshua McBride. I'm a technical solutions specialist with KETIV. We have a long history of knowledge sharing here at KETIV. We not only have the existing KVA, in which we get more into the technicals of the product, but we've started this initiative as well. You can see we have a number of companies that are involved in this. We'll actually have some customer stories shared today. I'll just be reading some quotes from them. We'll actually be doing a presentation in our next one here in about a month involving a customer success story. So if you have a success story, something you want to share, we would love to get you involved. We have thousands of viewers through different platforms. This is not the only platform we're streaming on here. And of course, this is viewable later as well. So just we're going to have a quick introduction of kind of who I am, my history. We'll have a poll, kind of get an idea from you guys on some things. We'll have try to keep it around 20, maybe 30 minutes max on what is digital manufacturing and the transformation, why we want to adopt that. Once again, I'll have a few customer stories, success stories in there. We'll actually have a prize for those that are attending on Zoom. So if you're not on Zoom and you're watching somebody somewhere else, you might want to hop over. Then we'll have time for a little Q&A as well. So moving right along, I am Josh. I'm a technical solutions specialist with KETIV. Before KETIV, I have about 20 years in the manufacturing engineering area, done a whole lot of different things, started a quality department, brought that company to be ISO compliant, did a plant expansion, doubled the plant size while cutting the transit distance for the product in half. All kinds of things, project management and stuff, and constantly in and out of the engineering department. So a quick fun fact about myself. This is what I like to do on the weekends. Yes, that is me. No, it's not as crazy as you think. It's actually relatively safe, but it is incredibly fun. So, all right. So how to win free stuff. We're going to have at the end here, you must be in attendance to get it, but we're going to have a $70 value prize. It will consist of a book and a gift card to Amazon. This is once again for Zoom only. You have to be present to win. So if you're watching somewhere else like YouTube, hop over to Zoom so you can get on this opportunity. All right, well, let's go ahead and launch our poll here real quick. The idea is, what is digital manufacturing? Is it just a set of tools such as CAD CAM? Is it AI computing, automated machines for manufacturing, or digitization of data? Digitalization of data seems to be the leader here. We'll go ahead and end that. And let's cover real quick what we talked about last time, because it feeds right into this. This is a true series in which each one will build on the other. So last time we talked about the continuously disrupted market that we face today, and the fact that it doesn't just require innovative solutions, but really new solutions. We're facing issues that we've never faced before, supply chain issues that, in fact, the current estimate is that we need 85,000 truckers just to meet current demand. The other side that everybody seemed to hit on last week was the issue with the fact that we have a large number of jobs that required skilled workforce, but we really have a lack in that area of skilled labor that we need. It's always been the opposite direction, in which we've always had a market in the past when we had these types of issues, in that we had not enough jobs, but plenty of labor. Whereas now we've got plenty of jobs, but we really don't have the skills to fill in those jobs as needed. Ultimately, we found that there is an opportunity for growth, but that opportunity comes if you embrace the you see the difficulties as opportunities and you embrace them as opportunities and utilize them to your advantage. Kind of stated that already. The problems are really opportunities for improvement. We talked about the transformation cycle. We're going to see that a lot today. Really, the key with this transformation cycle is that it is a continuous, never-ending cycle. If we ever stop in this cycle, then that just leaves opening for other companies in our competition to overtake us, right? So we want to make sure we're constantly improving and taking advantage of the tools and abilities that are set before us. We kind of hit a little bit on what the solution was here. So we'll once again look at that real quick. And that's what we're really going to get into today. That really digitally mature companies are 3 times more likely to report annual net revenue growth and net profit margins. Digital transformation study found that enterprises that apply the digital transformation principles broadly and deeply perform better financially. And so we're really talking about a culture change there. That's something we're going to get into in a future session as well. Digitization, AI, and automation are top drivers of productivity and profitability in the future, right? So what is digital manufacturing? Let's really get into it here. If that's the solution, then we got to understand what that solution is, right? So the typical belief is CAD, right? CAD, that's digital manufacturing. We're producing a product in the digital domain. Things like CAM, most companies are that have machines, automated machines are at least familiar with this, that we can run some simulation, prepare the models for those machines. Simulation, we can simulate different scenarios, simulate our product, those types of things. And if you've really kind of looked into this concept, you might have come across the idea of the digital twin. And so the question is that what digital manufacturing is? It's CAD, CAM, simulation, digital twin. That's it. Well, really, these are the tools that are employed in the digital transformation and one of many tools that can be employed in the digital transformation. But that is not what the definition of the digital transformation is. So if these are just tools, then what is digital manufacturing and the digital transformation? Well, it's the digital virtualization of data, processes, and analysis. And so once again, those are just tools that we can utilize, and there's many others. And the key here is the purpose of this digitization, the purpose being to enable our highly skilled workforce to achieve more, to increase our efficiency, connectivity, and advanced analytics. And once again, this gets right back to what most of you highlighted in the previous presentation, that it's the lack of highly skilled workforce that is the current big difficulty. So there's several areas in which this can really be broke down. The first is data collection. Okay. The first most obvious is typically product definitions. You know, we look at dimensions, materials, and things like that. We're typically capturing that in a 2D situation, which we can disseminate that out as either prints or PDFs or whatever. But what about time and cost to produce a product? That's data too. What about the distance between machines, or the distance and the time it takes for a person to walk from one place to the other in order to get their tools? It might even be, how far does a person have to reach? How often are they reaching? That's all data that can be collected and utilized. How about how many sales opportunities? What about the number of quotes? The number of quotes versus the number of sales, the time to produce a quote. Once again, this is data that can be collected that can provide us information. Most used purchased parts and most used or purchased products. What are the most profitable products? These are all pieces of information that can get us into this cycle that we're trying to get into here. We can use this data to increase our efficiency, find where we're lacking, find where we're doing the best, and focus on those things so that we can ultimately increase our productivity, our quality, produce more sales, margins, and revenue go up, and then we can reinvest again. So we'll read through this quick customer example here. This is ME Elecmetal. They know there is a value to solidifying and securing their workflows and assets on a single platform. Because of their global reach, they needed to select a cloud-based platform to standardize upon. They wanted everyone company-wide, everywhere in the world, at any time to be able to easily connect to the same information. And this centralized and shareable information is something I'm really going to hit later. So Michael and the ME Elecmetal team reached out to KETIV to obtain Autodesk Fusion 360 Manage, realizing that the product and the partnership with KETIV would result in a flexible PLM solution that can adapt to the business. They ultimately have a long history of partnership with KETIV, so getting started was easy. The teams are integrating the existing instance of Vault and Fusion 360 Manage and are working to build out custom workspaces for engineering change orders and proposals. They're establishing workspace fields to manage ECO direction for each project and are supported by an associated workflow that allows for tracking of each project or ECO in the system. So the key here is the focus on data and the sharing and of that data, the connectivity, making it readily available for people to ultimately make the best decisions possible. That leads us into the next piece. With that data, and we really have to start with data. So with that data, we can get into other things, and that is simulation. So we can look at things like tolerance stack up, stress, fluid flow, thermal, electromagnetic simulations. And I really want to hit the tolerance stack up here real quick because that's something that's readily available in Inventor, but is so rarely used. That can be used to either broaden the tolerances and look at, okay, how tight do we really need to go? And so we can reduce the cost of that part or that mold or whatever. Or maybe we're having issues and it's a tolerance stack up that we're not recognizing. We can simulate that. And once again, stress, fluid flow, and so forth. These are all ways that we can utilize our data to then simulate and improve the product, or even design a new product or meet customer requirements to a greater degree and get the most out of that customer or out of the product, and that therefore get the most in customer satisfaction. Multiphysics. This is something that's relatively new, and that's the ability to simulate these different things at the same time, right? As something gets rises in heat, then typically it's going to not be able to handle the same amount of stress, right? And in fact, stress can impart heat to the object. That in turn, that heat can also, and stress can affect the electromagnetic properties. That can be good or bad, right? Depending on the scenario. Heat can allow something to transfer more electricity. It can also become a hindrance. And the ability to simulate all of that at once is a huge advantage. Generative design, the ability to once again take data, take the important data, and then produce something, have a computer actually produce multiple scenarios for you based upon your requirements, not just where it's going to connect, but even the manufacturing process, and be able to produce something that is stronger requires less material, can be made in greater numbers quicker, and have a computer figure all that out. What about moving machines and materials around the shop? We can simulate that. Look at, okay, if I move this machine here, what effect is that going to have on my process as a whole? What if I put the material here and make it more accessible? How is that going to affect the whole shop? And we can simulate the whole process of production as well, so that we can see what one little change can have on the whole. What about new processes? We have a new product and we have to integrate that into our shop. We can simulate that. But what about the office or sales areas? We can run simulations and scenarios in order to better understand the customer, make sure we're getting the customer information we need, that it's going through our office as efficiently as possible, getting the results back. In addition to that, what about product configurations if they're prioritized differently? If we prioritize on price, what do we get as a result? If we prioritize on quality or performance, what is the product going to look like with the same customer requirements, but a different priority? We can get a completely different solution. Those things can all be simulated as well. And once again, that gets us back into the efficiency, productivity, quality, increased sales margins, and revenue cycle that we want to continue and keep going. So let's look at an example real quick from a customer. IDEX Health and Science, they had 3 goals. They wanted to understand the source of voids and leaks in their product. They wanted to adjust the mold for optimal fill and get product release back on track with minimal spend. So ultimately, they imported the model into a simulation environment provided by Autodesk Moldflow. They were able to visualize the cause of the voids and leaks. They uncovered that the sprue placement was the root cause of the problem. They were able to digitally test solutions and alterations to the mold itself. So we see here in a matter of hours, they had proof that a more costly change was essential to produce a mold that would achieve the desired outcome. Without simulation, the team would have eventually arrived at the same conclusion through multiple cycles of updating the tool, producing a molding run, testing parts, and identifying the issue. Moldflow allowed them to reduce several months of review cycles to a single month, which permitted them to go to full-scale manufacturing sooner. Of course, all that equals gains, right? The quicker they can get that product out, the more money they're making, the reduction in mistakes, the numerous molds that they would have been paying for to have made, and so forth. So let's look at automation. Ultimately, any repetitive task can be automated, right? And once again, we still have to, this still goes back to data. We have to have the data so that we can produce the automation, right? And so with that, we can automate the drawings or the assemblies of parts and pieces and drawing creation. And that's pretty common. But what about machines using design data to automate those so that we can produce more parts quicker and more rapidly, and getting that data directly from the model and the drawings directly to the machines? What about complete customizable or customized configurable products based upon customer provided data, rather than having engineers sit down and make these same decisions over and over and over again? We can have a machine, or I should say a computer, do that, right? So if the customer, in this case, say they are carrying a particular product, well, that is a point in which the type of truck that is going to be utilized gets narrowed down. The amount of weight can determine, from the engine, the transmission, to the tires and the suspension. And just off that one piece of information, that can really not only reduce the amount of time your engineers are spending making these decisions, but then we can actually automate that whole process and get it directly into the hands of the customer and have total confidence with the results coming out. We can also automate processes. So things that we do every day, right? Particularly, our office personnel. Work is constantly being assigned, approvals are needing to be obtained. We got to check up on the status, depending upon all types of scenarios. We have to set priorities, and the priorities are constantly changing, right? Particularly in the current environment. Priorities are constantly shifting. Enormous amounts of time are spent doing this, which we walk over to the guy's office or the cubicle. Well, he's not there. I'll try and call him on his phone. Well, he didn't answer. And, I'll wait till he gets back. And there's all this waiting time, and there's plenty of time spent trying to get a hold of the person. Something as simple as, where is somebody at on a project? I don't know if I need to shift that priority yet, because I don't know where they're even at on that situation. So once again, I'm waiting on this person to try and get a hold of them, to get an email back, or to open my email in order to just find out where they're at on that so I can even make a decision. All of that is lost time. And when we look at takt time, right, the total time to produce a product, more than just the shop is involved in this. This is a process that is highly involved in this. Well, we can automate that in such a way that you have a central place that you can go to get the information you need, provide the information to others. They can get an immediate pop-up on their screen saying, hey, you need to work on this instead. Depending on what they were working on, maybe they're already working on it. The system knows those types of things. And once again, we're back into increasing our efficiency and back into this cycle. One last customer example here, Bauer compressors. They had implemented a third-party nesting solution that they hoped would meet their needs and free up time for laser programmers. However, this new program did not integrate well with their existing vault infrastructure, which was essential to their designers. So they needed the integration between the two systems to be automated and seamless instead of the current manual process. So Bauer knew that implementing automation technology would enable them to keep up with their evolving business goals. So KETIV created automation that worked with the Vault Professional system using Cool Orange Power Jobs extension. This automation passes files of specific sheet metal parts to a location specified by Bauer. The file is then picked up by their external nesting software to be used during the cutting process for the part. This fundamentally triggered this functionality was triggered by a specific life cycle transition in Vault, which guaranteed that the correct version of these parts were being manufactured. So not only have we, once again, increased the efficiency of the engineers and the feeding of that information, but we've reduced errors, which ultimately are reducing scrap as well. So connectivity. Connectivity is really the key in all this. A lot of companies have a lot of data, right? We talked about that. They have a lot of data, but that data is not always accessible the way, and not easily accessible. And so the sharing and connectivity of that information is vital. The internet, that has revolutionized our whole way of life. And the internet is really just data. It's just based on data. The largest companies, some of the largest companies in the world, Google, Amazon, they collect data. Google, that's all Google does. They collect data and they disseminate data, period. Because data is that vital to our everyday lives. Amazon, oh, well, that's where we go to buy stuff, right? Well, but Amazon has found their success. They started as basically an online bookstore, but their focus was data in order to provide the best customer experience. Part of that customer experience means getting that product to you as quickly as possible, making it as easy as possible and quick as possible to return it, things like that, to provide you, the customer, with the best, most accurate information so you can make the best decision, right? And so that's the key here, is it results in better decision-making, okay? Connectivity, okay? I've got a laptop with right now 3 screens in front of me. I've got a cell phone, I got a tablet, I got another PC in the house. My wife's got a cell phone. I've got Google Home, a couple of those in the house, right? Smart TV, and I know there's people that have way more connectivity than me. It's integrated so heavily into our personal lives, but yet are we using that in our business lives? We understand how valuable it is to our personal lives, but yet oftentimes it's overlooked in our business lives. And that's where the most value is. And I've already hit on Amazon here. So we've talked about some successes, but I want to share a failure. Okay. And obviously I'm going to be keeping the company and the situation vague, as for understandable reasons. Okay. But one of the key things I want to highlight in this story is the avoidance, right? Instead of being reactionary, being proactive. And this is something we're going to talk heavily about in a future presentation as well. Because the thing is it's easy to react because we see the immediate results. But when you're avoiding something, you don't know that you avoided it because it never happened. Okay. And so in this example, as most companies are, they're kind of a conglomeration of companies. These companies have been purchased over a number of decades. And they all, as part of their product, utilized the same, a piece of this that was patented. And they all had slightly different versions, but they all fell into the same patent. And at one point they decided that they were going to improve this product. So each of them, all three of them, started their own R&D on this product. So that's three times the cost in R&D right there, because they're not sharing data. So they all came up with their own variations and they started producing those. One of them began to fail in the field. The failures cost millions of dollars, millions. The other product, the other two, one of them, basically that was one piece they had decided not to change. They just never got into that analytical piece. The one of them, they had previously encountered that scenario. They had done extensive testing and had extensive data to know what the problem was, why this was occurring, and it was ultimately resonance, and how to prevent it. But that data was not accessible and not shared with the other teams, ultimately resulting in the same failure happening again, costing millions of dollars. And of course, there's untraceable cost, right? Due to the loss of customer confidence. We don't know how many sales are lost due to them seeing those failures and going, yeah, we don't have confidence in these people anymore. So that's the other thing in all this, is to become proactive versus reactionary and avoiding those types of horror scenarios in that sense. And so once again, back to the transformation cycle, keeping it going. So the digital transformation, where can it be applied? Why do we want to adopt it? Well, we can adopt it. We've talked about all that. And ultimately, I think we've seen that it can really be applied anywhere, right? Whether it's through sales configuration or CAD automation, engineering design automation, simulation and testing, advanced manufacturing, and all of that can be connected with data management so that it is all shared amongst all the processes, shared amongst all the different manufacturing facilities or whatever that may exist across the country, across North America, and so forth, with across the world, right? And then process system integration so that they not only sharing information, but they're integrated with each other. Sharing information, feeding the process, kicking off simulation or automation, and those types of things. And this is where KETIV really comes in. And the reality is KETIV has gone through a lot of this transformation ourselves. We're continuing to do that. And with COVID, companies have reached out and started this transformation really immediately. And COVID has put us in, and this is something we talked about previously, it's put us in a situation and not just us as KETIV, but all of us into a situation that we've never encountered before. And so we can help in any of these areas. We have, once again, tools. There are tools that are available to us. We have, the marketplace and COVID's effect has had a huge effect on KETIV, and we've had to shift our business to meet that. Instead of scaling back, ultimately we scaled up with connectivity, remote work. I'm actually, KETIV's based out of California. I'm in Oklahoma presenting right now. The complexity of an expanding portfolio. We have expanded dramatically in the tools that we have available to us, in the skills that we have available to us as well for custom automation in all areas of the business. Once again, we don't have a limit in the manufacturing world as to where we can automate and help and utilize tools. And ultimately, this has moved KETIV further along the maturity scale in the digital manufacturing world. So real quick, we have another session March 9th. We're going to continue to discuss this. Once again, each one builds on the other. We also have the KVA that is more focused on each individual tool, and kind of some tips and tricks are shared as well as just what those tools are and stuff. And those are intended for more the user level people. And then of course, if you have any topics, suggestions, anything you want to hear about, we'd love to hear that as well. If you have something you'd like to share, we'd love to hear that as well. We've already talked about this, the KETIV Virtual Academy. Here's kind of a list of all the different areas that we cover, a broad range of areas, and we're continuing to add to that. We have some new areas here with Tacked-On, Pinnacle, are relatively new areas, and we will be covering those. We recently had one on Tacked-On. So with that, we can open it up for if anybody has any questions, we can kind of cover that now. Otherwise, you can always email me, joshua.mcbride@ketiv.com. You can give me a call, connect on LinkedIn. You can contact marketing@ketiv.com. And with any questions, or if you want further discussion, you have a scenario that you want us to look at, maybe help you with, we are always available to you. All right. Well, I appreciate your time and attendance. I hope this was educational. And once again, I will be doing this again next month, and I hope to see you all then. Have a wonderful day.